In this video, we are going to talk about polynomial functions. All right, so first off, I want to give you some examples of polynomial functions. So here is a polynomial function, and here's another one, p of x, and another one, q of x, and another one, r of x, and finally another one, s of x. Okay, so polynomial functions consist of what's called a linear combination, so addition or subtraction of terms that look like this. So the terms look like some number times x to a power, and that power needs to be a whole number, right? And it also needs to be non-negative, right? The power. So x to the fourth, right? That's x to some positive or non-negative whole number power. And so that's what all of these polynomials have in common. They all are consist of a bunch of terms, right? Things that are being added or subtracted, and the terms all kind of look the same. It's some number times x to a non-negative whole number power. Okay. All right. So here you can see that's to the fourth, to the third, squared. Here the power is missing, right, and it's understood to be a 1. Here you can see that there's no x involved, right, and so that's allowable too, right? That has to do with the fact that x to the 0 power is equal to 1, right? And so you can kind of consider these terms without the x, as the constant terms, as having this x to the 0 power. And so again, the power is non-negative, and it's a whole number. Okay. All right, so that's what all of these have in common. You can see this one has a fraction as one of the numbers. That's fine. It can have a fraction as one of the numbers out in front. It just can't have the fraction in the exponent part here. Here are some polynomial functions that we've already talked about, right? This one is just a quadratic, so a quadratic function is also a polynomial function. This is a linear function, right? So a linear function is also a polynomial function. So you can think about polynomials really as generalizations of these functions that we've already studied in this class. All right, so here's the definition. If n is a non-negative integer, right? Integer, again, is just another word for whole number, essentially, right? It's a polynomial function is a function that can be written in this form. So it's some number times x to some non-negative integer power, right? Plus, right, another number times x to some other power, and so on and so forth, all the way down to the constant term. That is the term without the x there. So that's what a polynomial function is, pretty much exactly what we talked about in the previous slide. This form is called the standard form of the polynomial. All right, and the highest power of x when the polynomial is written in the standard form is called the degree of the polynomial. And the numbers out in front of the powers of x are called the coefficients of the polynomial, or p of x. The term containing the highest power of x is called the leading term of the polynomial, and the coefficient with the leading term is called the leading coefficient. Okay, so for each one of these polynomials, what we want to do is to find the degree, the leading term, and the leading coefficient. All right, so the degree here on this one would be 4. So that would be 4. The degree on this one would be 14, because that's the highest power of x. The degree on this one would be 5. The degree on this one would be 2, right? Because the highest power of x is 2. even though it's not written in descending powers of x like these others are. And the highest the degree of this one is 1 on this one. Okay. All right, the leading term is 3x to the 4th on this one, 3x to the 14th on this one, negative 7x to the 5th on this one. It is minus 5x squared on this one. And it is 2x to the 1 on this one. And then the leading coefficient of each of these polynomials, the leading coefficient here is 3. Leading coefficient here is 3. The leading coefficient here is negative 7. The leading coefficient here is negative 5. All right, and that can be a little tricky because, you know, your eye is just kind of drawn to the 5 itself, right? But if it's negative and it's not written in descending powers of x like this, you have to remember to take the negative along with the number if it's there. Okay, and then here is the leading coefficient is 2. All right. Okay. Now, this last example is a little bit tricky because of the fact that it is not written in the standard form. It is written in the factored form. Okay, so that is a little bit complicated about as to figuring out what the degree and the leading term and all that stuff is, right? So technically, or the kind of the long way to do that is to completely multiply all this out. And it takes a little while to do that, okay, to multiply it out. That's fine. You could do that way. And then what you'll wind up with, right, if you multiply all that out is, and I'm not gonna work that out, but if you do that, you're gonna wind up with negative 3 times 2 times negative 4 will be 24 x cubed okay, and then plus, right, some other terms over here, and I would only really know what those terms are if I completely multiplied this thing out. Okay, so I'm not going to do that, but actually, it might be worth taking the time to go ahead and do that because this one is actually not too bad. So let's go ahead and do that, and just so you can kind of see how that works. So, all right, so I have minus 3x, 2x minus 1 times 1 minus 4x. All right, so I'd multiply this out, these two out first, and FOIL these out. So I get 2x, and then outer times outer is minus 8x squared. Inner times inner is minus 1, and last times last is plus 4x. All right, and then simplifying the inside here, I get minus 8x squared plus 6x minus 1. And then I would have to distribute this minus 3x through the parentheses. Okay. So when I do that, I will get 24x cubed. Right, because negative 3 times negative 8 is positive 24. X times x squared is x cubed. And then minus 18x squared. and negative 3x times negative 1 is positive 3x. All right, and so you can see I was right about the leading coefficient. And so the question is, okay, how was I able to tell because on this one, because it was not multiplied out? So this form is what's called the factored form. Okay, so this is where this polynomial has been completely factored. And so the trick is really, what I did was look at the coefficients, right? Oops, let me make that a little bit better. I looked at these as three separate polynomials, right? I looked at this as minus 3x, and that would be the leading coefficient of that one. And then 2x as the leading coefficient of this one, or the leading term, and then minus 4x as the leading term of this one. And then I just multiplied all those things together. So minus 3x times 2x will give me minus 6x squared. Minus 6x squared times minus 4x will give me 24x cubed. So just by multiplying those out, that's what got me the leading term here. And so that's a useful skill to be able to have in this section that we're studying about polynomials. And you can kind of see how it works, right? Just by going through this multiplication. Here the leading term was 2x, and here the leading term was minus 4x, right? So we got minus 8x squared as the leading term of this one. And then the leading term of this one was minus 3x, and you can see when I multiplied those, I got negative 3 times negative 8, positive 24, x times x squared is x cubed, okay? So the degree of this one was 3. The leading term was 24x cubed. And the leading coefficient was 24. All right, so that's a little bit tricky. If the polynomial is written in the standard form, right, all multiplied out and everything, then it's pretty easy to pick off what the degree is, what the leading term is, and what the leading coefficient is, okay? If the polynomial is written in the factored form, however, right, then you are going to have to do a little bit of work, right? You're either going to have to take the time to completely multiply out all of the polynomial and get this, and then then it's in the standard form, and now it's easy to get those the degree, the leading term, and the leading coefficient. On the other hand, if you know the trick that I told you, right, just to multiply, if it's in factored form, take the leading term of each factor and multiply them together, and that will give you the leading term of the polynomial, and then you can just pick off all the answers from here, okay? So again, that's a pretty nice trick to have. All right, so it is also helpful to take a look at some functions that are not polynomials. First off, this one is not a polynomial because of the square root. This 3 is okay, the minus 2x is okay, and the minus 4 is okay. Everything's good except this square root right here. The square root is really a fractional power. Square rooting x is the same as raising x to the 1/2 power, and in polynomials you can't have fractional powers like that. So that's the issue with that one. This one is a big fraction with a variable in the bottom part. You can't have that with polynomials either. You can kind of try to do something like pull this apart and write it like so, which is a technique that I showed you in class for some other topic. And when you do that, you get x divided by x, which will be 1 as long as x is non-zero. And then 1 over x is really the same as x to the minus 1 power. And you can't have that. So the issue is that I have this division with a big x in the bottom. You can't have that in a polynomial. It has to be x to some number power, and this is not it. Even if you try to rewrite this and say, hey, this is x to some number power, this is not one of the powers that you can have, right? Remember, the powers in a polynomial have to be non-negative whole numbers. So whole numbers that are 0 or bigger. Okay. All right, next one. X to the 1/3, that ruins that right there. In a polynomial, I can't have fractional powers like this. So that's the part that makes it. Here is this absolute value. That ruins, you can't have that in a polynomial either. Now, if the absolute value were gone, then this would be a quadratic, which is a polynomial, right? So you can't have this, you can't have this, you can't have this stuff in polynomials. Okay, so in the rest of this section, we are going to look at a couple of issues involving the graphs of polynomials. One is called the end behavior, and then the other is zeros, are called zeros, and then multiplicity of zeros. And so the first is that we will look at the end behavior, and we will do that in another video.